Okay, see Lindelof videos, calculus and implicit differentiation practice number 2. I'm going to do 2 problems really quickly just so you get some practice. I'll walk you through this a little bit. So this is what we're looking at. We see this y value here brought up to an exponent that's not equal to 1, and also another y value here. So it gets kind of sticky and trying to figure out, well, how are we going to differentiate this? So we're going to differentiate it implicitly. So what I'm going to do is this. This is just my notation. I'm going to make this declaration that I intend to take the derivative of this whole thing. Again, I'm not distributing this ddx thing, but I am saying it is my intention to take the derivative of each of these things by part. So that's what I intend to do right now. So ddx of 4x squared, of course, is 2 times 4 is 8x, right? It gets a little bit dicier here, and this actually turns into the chain rule. It just doesn't look like it. It looks like the power rule. But if we can keep in mind that we have this inner function here, so it looks a little bit like this. Take the derivative of the outside piece. So I'm going to use the power rule here. 3 times 2 is 6. 6y, not to the third power, but 3 minus 1 is 2 to the second power. However, now I'm forced to take the derivative of the inside piece. I'm forced to take the derivative of y, right? This is my chain rule. So here's the derivative. This is the derivative of the outside, and the derivative of y is dy dx, the derivative of y with respect to x. Now I'm going to do the same thing here. I'm going to take ddx of 4y. So I take the derivative of the outside piece, and the derivative of the outside piece is just 4. And then I'm going to take the derivative of the inside piece, and the inside piece is y, and the first derivative of y is dy dx. This one works itself out kind of nicely because all the dy dx's are on the same side. So what I am going to do is I'm going to factor out these factors of dy dx. So I'm just going to rewrite here. This is my 8x, and now I'm going to factor out there's a dy dx here and a dy dx here. So I'm going to factor out dy dx and dy dx times 6y plus 4. And if you look, if I distribute this back in, then I would have 6y squared dy dx, and then I would have 4 dy dx. So it does match, it works. Now what I'm going to do is I'm going to divide the whole thing by 6y. Wow, what's this crap down here? By 6y squared plus 4. So I'm going to do that, and I'm going to get 8x divided by 6y squared plus 4 equals, and my dy dx is here. Dy dx. Remember, oftentimes what's going to happen, especially on the exam, is that you're going to be asked to take the derivative at a point, and they're not going to ask you to differentiate implicitly. You're going to have to see this and say, no, because of this, this is going to be implicit differentiation. And more than that, what you're going to have to think is, when they give you the point, you're going to have to put in not just the x value that they give you, but also the y value that they give you to get a numeric solution back. So let's try just one more together, all right? Maybe not? I thought we might. Did we do 2? Am I that good? Holy crap, I am that good. All right. Any questions or comments, let me know. Hey, if you haven't already subscribed, will you please? I appreciate it.